everyone, so this will be our second lesson under the topic of algebra. So after today's lesson, we'll be finishing the first chapter in your textbook. But if you refer to your syllabus, right, it's actually not the end. So it's just that your textbook is trying to split the chapter, split the topic itself into like two chapters. Okay, so today's learning outcome will be only one thing, which is you need to learn how to use the factor theorem and remainder theorem. I know that you learn this in your IGCSE and Max syllabus as well, but then it will be something that is like different or like much more advanced because when you look at your learning outcome, right, they stated that it's including the factors of the form of ax plus b in which the coefficient of x is not unity. So unity basically meaning 1. So what you have learned previously is mostly like x plus a or x minus a only, so you do not have something like ax plus b. But actually the concept itself is like similar, it's just that you are learning like the fractional side also. Okay, you will learn how to find factors and remainders using the theorem. Then after that, you know how to solve the equation and how do you use this theorem to help you to evaluate some of the unknowns in your polynomial. Okay, so that's the idea for today's lesson. Alright, so before we move into the content, let's do a very quick recap on what we have learned previously that will be much more helpful for us to continue today's lesson. Okay, last lesson we talked about the division for polynomial, right? Then at the end we talk about that something that is called division algorithm, which we say that the dividend of the polynomial is basically equals to the divisor multiply the quotient and then plus the remainder. I hope that you still remember. So dividend is basically your original polynomial equation or expression. Then after that, your divisor is the term that you use it to divide. Then the quotient is your answer. The remainder is what you left after you do the division. Okay, so sometimes we can write it in the way that is like a polynomial will be equals to the divisor multiply the quotient and then plus the remainder. Okay, so this is what we have learned in the last lesson. So we will be using this algorithm to help us to prove how is a remainder theorem look like. So after we go through the remainder theorem, then we will use remainder theorem to see what is a factor theorem. Okay, so you can see that in your worksheet, I try to like have some empty spaces here. So those are the spaces that you will need to fill it in later. Okay, so let's try to look at your handout. Okay, so if for a polynomial px is divided by x minus c, the remainder is pc. Okay, how are we going to prove that? I mean, how am I going to know that whether this statement is right or wrong? So it's in bold color, meaning that this is what is that mean by the theorem itself. Okay, so you see, we have this thing, right? Okay, so if the polynomial is divided by x plus c, so meaning which part of this is x minus c. So divided, right? So meaning that your divisor is x minus c. Okay, so now let's try to put it in. So meaning that my polynomial x will be equals to, so my divisor now, because it's divided by x minus c, so that's why I changed my divisor into x minus c. Okay, then after that, I have my qx, and then plus the remainder for my x. Is that okay? So meaning that it's still the same algorithm, but then I know that my polynomial is divided by x minus c, so that's why I changed my divisor to x minus c. Okay, now when you look at this one, right, when you have a divisor that has a degree of 1, because x the power, the highest power in this expression is is 1, meaning the x power 1, right? So we in a previous lesson we also discussed that for the remainder always have a degree that is less than the divisor. So meaning your r here must be a constant. because the degree here is 1, so that's why your remainder must be having a degree that is 0, right? So x0, which brings you a constant. So meaning that we can change it to your polynomial will be equals to x minus c qx plus r. So because it's a constant already, so meaning that you do not have any spaces that you can substitute the x, right? So we just leave it there. Okay, so now since that what we want to find here is like PC, so let's try to substitute the x here. We change it into c and see what happens. So PC is equals to, so since you substitute the place x to c, so meaning that we are doing c minus c, correct? So we are substituting all the x to c. So c minus c qc plus r. Okay, then after that you see c minus c, what do I get? I get 0. So 0 multiply qc, I get 0. So it becomes 0 plus r. So what does that mean? 0 plus r, what do you get? You get the r. So PC is equals to r. Actually, why is that happen? When you look at this equation, you know that if I try to make the expression here to become 0, then I know that I will eliminate the q also, because anything you multiply with the 0, then I get 0, right? So plus remainder, so meaning that I will left with remainder. So that's why this is like a theorem to help us to find out what is the remainder without doing long division, just by substitution. Okay, so the same thing, let's try to see the second one. So the proving part, let's try to change it. Okay, px equals to, so now the polynomial is divided by ax minus b, right? So that's why your divisor is ax minus b. Okay, so your q is qx also, and then plus rx. So it's the same thing, ax minus b, the degree of the polynomial is also 1. So that's why I know that my remainder will be always a constant as well. So I can no need to write the x thing. Okay, so now let's try to move on. Okay, so the same thing now. How can I change this part into 0? So that's why you can see what we try to do is we substitute b over a. So ax minus b equals to 0, then I get b over a, right? So b over a. So you see what happened when I substitute b over a. So a multiplied by b over a minus b, then q b over a plus r. Okay, so the same thing you see. When a and a divided by a, then you get 1. So 1 multiply b, then you get b minus b, you get 0. So again, your divisor part becomes 0. So 0 minus your multiply your quotient, you get 0 as well. So it becomes 0 plus r. So equals to r. So this is why we say that if your polynomial is divided by ax minus 1, the remainder will be the same if you substitute b over a into the equation. Okay, alright, so this is what is that mean by the remainder theorem. So now you can try to think it like in a further, so meaning that you see now we have like px equals to x minus c qx plus r, right? So we say that if we have PC, then it's equals to r. So the same thing for the other one, px equals to ax minus b qx plus r. So my b over a is basically equals to my remainder. Okay, so now what happened if I get, because we know that in previously you know that some of the polynomial can be completely divided, or sometimes we say that can be divisible by the other polynomial, right? So what happened here is if my r is 0, meaning that if I get my PC is 0, what does that mean? It means that the divisor can divide the polynomial completely. So what is the name that we give to the term itself? It's basically the factor. So that's why x minus c is the factor. So this is how we come out with the factor theorem from the remainder theorem. Same thing, if here your R is 0, meaning that your P B over A is 0, right? So what does that mean? It means that your AX minus B is basically the factor. Okay, so this is what is that mean by the remainder theorem and the factor theorem. So now when we try to look at the questions, maybe you can have a better idea of it. Okay, use the remainder theorem to find the remainder when 4x cubed minus 2x squared plus 5x minus 1 is divided by x plus 1. Okay, so the same thing. What we try to do here is we try to define our function first. So let fx equals to 4x cubed minus 2x squared plus 5x minus 8. Okay, so you remember from the remainder theorem, we know that if the polynomial is divided by x plus 1, meaning the remainder will basically equals to the function substitute with negative 1. Okay, so from the equation just now, yeah. Alright, so if x plus x minus c, then we substitute c. So now it's like x plus c, so it become negative c lah. Okay, so f negative 1 equal to, so you write down 4 negative 1 minus 2 negative 1 square plus 5 negative 1 minus 8. Okay, so you will use your calculator to get your answer. So maybe let's try to write it down. Minus 2 plus minus 5 minus 8. So negative 4 minus 2, negative 6 minus 13. So you get negative 19. Alright, so your remainder is basically equals to negative 19. Is that alright? Yeah, so I hope that you can get the idea like why you do not need to like change it into the form. So maybe I'll just do a very quick explanation here. So it's like the same thing if I'm having like fx equals to x squared minus 5x. This is like the other example, okay? Plus 6. Okay, so if we know that when you try to factorize this, then you will get x minus 3x minus 2, right? Okay, so when I substitute f1, right, is it the same if I substitute here or I substitute here? It will definitely give me the same answer. So I 1 minus 5 plus 6, then negative 4 plus 6, you get 2. So negative 2 times negative 1, then you get 2. It's basically the same thing. I do not really need to factorize it before I can substitute. So it's the same answer. Like for example, I know that for this term, if I substitute 3, it will become 0, right? So let's say f3. Let's say I want to make this term here become 0. So when I substitute 3 squared minus 5 times 3 plus 6, then I get 9 minus 15 plus 6, I get 0. So it's the same thing if I substitute like f3, then 3 minus 3, then x minus 2. It's just that it becomes like obvious that this part becomes 0, and when I times anything with 0, I get a 0. So that's why I do not really need to arrange them into the part like qx times my dx times my qx plus my remainder, then only I can like write down. If you already do this in the term, then what is that for if you come up with this theorem? Because you still need to do everything in your long division. Okay, so basically this theorem is to help us like to find the remainder without the need to do the long division itself. So meaning that actually we do not know what is the quotient, but we know that the remainder will be negative 19. Alright, okay, so let's go to number 2. Use the factor theorem to show that x minus 3 is the factor of x cubed plus 2x squared minus 16x plus 3. Okay, so you remember just now, what do we say that, what is that mean by the factor theorem? Is that when you find the remainder, you get the remainder as 0, so only we say that the term itself, the divisor, is the factor, right? So meaning that what do we need to do here is we need to prove that when we substitute 3 here, I will get the remainder as 0. So let's do the same thing. Let fx equals to the equation that I want to deal with. Alright, so since that I want to show x minus 3, so meaning that what is the number that I need to substitute here? It becomes 3, because 3 minus 3 I get 0, right? So 3 cubed plus 2, 3 squared plus 16 times 3 plus 3. So 3 cubed, 27, and then plus 18, yeah, plus 48 plus 3. Sorry, did I put, oh sorry, this is minus. Alright, so here I get 45 minus negative 3, then plus 3, I get 0. Alright, so since f3 equals to 0, it means that your remainder equals to 0, right? So meaning that my x minus 3 is a factor. Alright, I hope that is not too hard for you. So it's basically substitute to find the remainder. If the remainder becomes 0, then it's the factor. Yeah, just like that. Alright, so let's go to number 3. So when the polynomial is divided by the x, 2x minus 1, the remainder is 3. Find the value of a. So it's basically with the given information, you need to solve the equation. Okay, so number 3. Alright, so it's the same thing. How can you write this in a form that in remainder theorem? So we know that this thing divided by 2x minus 1, the remainder will be equals to 3, right? So meaning that if I let my fx to become 16x power 4 minus ax cubed plus 8x squared minus 4x minus 1. So if I substitute 1 over 2, is that okay? So it's basically like your quadratic equation when you try to factorize and then you solve it. So 2x minus 1, basically if you want to make this become 0, then you need to substitute 1 over 2, right? So f 1 over 2 substitute, your remainder will be equals to 3. Okay, so if you have written this piece of information, then you should be able to continue already. So the same thing, 16, 1 over 2 power 4 minus a 1 over 2 power 3 plus 8 1 over 2 power 2 minus 4 1 over 2 minus 1 equals to 3. Okay, then you will continue to solve. 16 times 1 over, so is 1 over 6 minus 1 over 8a plus 1 8 1 over 4 minus 2 minus 1 equals to 3. So sorry, this is 16. So I get 1 minus 1 over 8a plus 2 minus 2 minus 1 equals to 3. So 1 over 8a will be equals to, so 1 plus minus minus no more, so I get negative 3. Okay, then I will continue with it. Okay, so my a will be equals to negative 3 multiply 8, which gives me negative 24. Is that alright? So yeah, below here is basically arithmetic calculation. What is important is you know how to continue like this step and this step. Okay, so basically the question tells you if divided by 2x minus 1, the remainder is 3, meaning that you substitute 1 over 2 into the polynomial itself, you should get the answer of 3, which as your remainder. Alright, so let's move on to number 4. So the polynomial x cubed minus ax squared plus 2x plus 8 is denoted by px. So maybe let us write down first. Okay, px equals to x cubed minus ax squared plus 2x plus 8. So it is given that x minus 2 is the factor of px, a, evaluate a. So you can see that this question is actually very similar to what we have went through just now, which is like the number 3. But then for number 3, when you divide, you get a remainder that is 3. So this question, they tell you that x minus 2 is a factor. So if x minus 2 is the factor for this polynomial, what does that mean? It means that when you substitute 2, you will get a remainder that is 0 because x minus 2 is the factor, right? So we do the same thing, substitute 2 in the equation. So 2 cubed minus a times 2 square plus 2 plus 8 will be equals to 0 because x minus 2 is the factor. Alright, so you can continue. 8 minus 4a plus 4 plus 8 equals to 0, meaning 4a will be equals to 20 and a will equals to 5. Alright, so after you get a, then let's move on to b. So when a has this value, factorize px completely. So what you can do here is basically what we need to do is like the long division that we have done previously. So now we know that x minus 2 is a factor, right? So meaning that if I can write x squared minus ax squared plus 2x plus 8, I would be able to write it in the form that x minus 2 and my quotient, right? Because my remainder is 0, so it's going to be like plus 0. So now I want to factorize it completely, meaning that I need to get my qx. So how can I do that? I can do the long division. So yeah, I'm going to show you like two ways here. So the first one is the I would say the easier way, which you just do long division like what we have learned yesterday. Okay, so you already know that the a here is 5, right? So we can write 5 already. So meaning x cubed minus 5x squared plus 2x plus 8 divided by x minus 2. Okay, so I'll do the revision like how we do normally. So x cubed minus 2x squared. So minus minus become plus, negative 3x squared plus 2x. So I get negative 3x. So negative 3x squared plus 6x, which gives me negative 4x plus 8. Sorry, plus 8. So negative 4. I get 0 here. Okay. So if you didn't get a 0 for your long division, right, then you might need to check again, do you do something wrong in the long division itself? Because if the question already tell you that x minus 2 is the factor, meaning that after you do long division, you should be able to get 0. So now we already know that it's going to be x minus 2 times with x squared minus 3x minus 4, right? So how can we factorize this completely? So do your quadratic factorization. So x minus 2. Okay, so when you factorize this, what do you get? Yeah, let me move up a bit. Okay, so when you factorize this, you will be getting x minus 4 and x plus 1. Okay, so to give you minus 3x and minus 4. Alright, so this will be your answer. Factorize it completely. Okay, how can we do it in second way? So since we learn a factor theorem here, right? So we know that if, so let's say, it's the idea of, if I tell you that 8 can be divisible by 2, so we know that 2 is the factor of 8. So when you use the 8 to divide, when you use 2 to divide 8, right, then you get the quotient as 4. So do we say that 4 is the factor of 8 also? Yes, right, because 2 multiply 4, you get 8. So meaning 2 and 4 are both factors of 8. So it's the same thing. If I do not have a remainder here, so what does that mean? Meaning my qx must be a factor of this also. So meaning that without doing long division, I can try to substitute and try to do like try and error, then for me to find that answer. So how am I going to do that? You can do it like this. So you have 8 here, right? So the possible answer for your, okay, you can imagine, you know that when you try to, this is in cube, so when you try to expand it, you will be getting like 3 terms, right? So I know that when you try to expand, then you will need to like times several things, then you need to plus or minus them together to put them in this form. But then what do you realize here is the first term and the last term is basically built by the first number and the last number, right? So meaning that x times x times x, you get x cubed. Then you see -2 times -4 times 1, you get +8. Because that's the last term, like no matter how you expand it, it's going to be the last constant term when you're trying to multiply them together. So in case for us to get 8, the possible factor is plus or minus 1, positive or -2, positive or -4, positive and -8. Because we already know that x squared is in front, so meaning that I already know that my 3 terms here must be always x. It cannot be ax, right? Because my x cubed in front, there's no coefficient. So I do not need to worry that I will have a fraction over here. Okay, so those are the possible value that that I can use to factorize it. So what is the further information for me to eliminate? Is that I already know that it's x minus 2. So you can imagine positive and -8 should be out already. Because if I have something that is doing with 8, right? When I use 8 to multiply 2, I wouldn't be able to get 8 here already. Because 8 must be paired with 1, then only I can get 2, right? So the other one are all possible, meaning like 2 times 4 times 1 or 2 times 2 times 2, I can able to get 8. So now I will need to do try and error. So for example, if I say that maybe x minus 1 is one of it, so meaning that when I do my P1, I should be able to get 0. So let me try. So P1, so I substitute 1 here. So 1 power 3 plus 5, 1 square plus 2 times 1 plus 8. Okay, so you check. So 1 plus 5. So definitely for this one, you are not getting 0 already. So x minus 1 is not the factor. Okay, so let me try the other one. Let's say P -1. So I'll try to put -1 power 3 minus 5, -1 square plus 2, -1 plus 8. So I'll check -1 plus 5, then I get let me write down, -1 and then positive minus 5 minus 2 and plus 8. So I get -8 plus 8, I get 0. So I know that if I substitute -1, it gives me a remainder of 0. So meaning that x plus 1 is one of the factor. Correct? So now I already know that one of it is like x minus 2. Then after that, one of it is like 1x plus 1. So by looking at this, you can roughly guess already what is the last one, because you know that it should be an x, right? So the last number, when you multiply them together, it should give you a positive 8. So -2 times 1, you get -2. So what do you need to times? You need to times a -4, then only gives you 8. Correct? So you roughly guess that it's like x minus 4. So let's check. So P, when you substitute 4, what do you get? 4 power 3 minus 5, 4 power 2 plus 2 multiply 4 plus 8. Okay, so when I try to substitute, then what do I get? So 4 power 3, I get 64 minus 16, so 80 plus 8 plus 8. So this one minus -16 plus 16, then I get 0. So I know that x minus 4 is the factor also. Correct? So this is how I know that my final answer should be x minus 2, x minus 4, and x plus 1, which is exactly the same like this. Okay? So actually when you look at the working, you should be able to know that actually this one is like much more easier, because you do not need to try to guess and then do a lot of like logical thinking or like you don't need to like try and yeah, this is wrong, then after that I continue with the other and so on. I can basically by doing division and get an exact answer. So this one will be very useful if let's say I want to solve an equation. So later we'll be using this type of method when we deal with number 7. But it's actually for this question, I mean it's not necessary for you to really do like this. So for this one you will be having a more exact answer and you can check also whether you get a 0 there. Okay, so but I'm just showing to you, you have an alternative to do that by using a factor theorem. Okay, alright, so let's move on to number 5. Given that 3x squared plus 5x minus 2 is a factor of blah blah blah, find the value of a and b. So this question is very similar to 3, 4 also, but I'm just putting in because the factor here is a quadratic. So if it's a quadratic, then what should we do? So let's say number 5. So the same thing, let's just try to denote it. So px, fx, anything. 3x cubed plus 17x squared plus ax plus b. Okay, so we know that this can be is a factor. So what should we do? So you remember for a factor just now, for us to make it 0, we must be able to factorize it in like linear form, right? So we will need to factorize it first. So 3x squared plus 5x minus 2. So when we factorize it, then what do we get? So 5x, 3x, I will be getting 3x x. Okay, so minus plus, so it's 6 plus 2 and then minus 1. Okay, so this will give us the answer here. So meaning that we actually have 2 terms here. Meaning that, what does that mean? Meaning that p 1/3, it will give us 0 also. The other thing, when we substitute -2, it will give us 0 also. Is that alright? So meaning if it's a quadratic, then what do you need to do? You need to change it into linear form. So meaning that 3x minus 1 is the factor of this polynomial. X plus 2 is also the factor for this polynomial. Okay? So after we have written down these 2 pieces of information, then now we can continue to find the a and the b. So substitution, 1/3 3 plus 17 1/3 square plus a 1/3 plus b equals to 0. Okay, so you can expand. So 1/17, so 1/9 plus 17/9 plus 1/3a plus b equals to 0. Okay, so you can move it around first, or yeah, like depends on how you want to solve it lah. So 1 plus 17 plus 3a plus 9b equals to 0. Then I'll be able to get 3a plus 9b equals to -18. So I'll just leave it there first. So we continue to the second one. P -2 equals to 0 as well. So substitute also. 3 -2 square plus 5 -2 y5 17 square plus a -2 plus b equals to 0. Okay, so next one, 824 plus 17 times 4 68 minus 2a plus b equals to 0. Okay, so maybe I'll write it in the form that I can continue with. So minus 92. Okay, so this is the equation that I have. First one, second one. So simultaneous equation. Okay, so 2 go into 1. So I'll get 3a plus 9, 2a minus 92. Yeah, so actually until here you should able to continue by yourself already. So make sure that you are not copying, so you can always like do it by yourself to check. Okay, 18 and then 1 992, so equals to negative 8. 21a will be equals to negative 18 plus, so I get 810. Okay, so you can continue. Yeah, I did a mistake here, negative. Yeah, so I hope that you are doing it by yourself so you do not have the error that I'm having now. Okay, 44, so this should be 44. So 936. Okay, then I should be able to get negative 18 plus 396, which give me 378. Okay, so 378 divided by 21 give me 18. Alright, okay, so you get your A already, so let's go to B. 2a here, 18 minus 44. So 36 minus 44, which gives me negative 8. Alright, so this question asks us to continue to factorize the polynomial. So let us write down the polynomial first. So 3x cubed plus 17x squared. Your A is 18 minus 8. Okay, so after you get this, then now I already have 2, right? So meaning that it will be 3x minus 1 and x plus 2. Then after that, I left with my last quotient. So how am I going to do that? So the same thing, so depends on you whether you want to, actually from this question, it's quite easy to guess also. Okay, so the first one, let us try to do the guessing part. So how are you going to know that? So you know that this thing will give you in exact, you already know that the remainder is 0. So it's supposed to be like this also. So this is x, so you know that this term must be having a linear form also, because the degree that you have is like x power of 3. So you can try to imagine like what is the term that you will need to multiply so that you can get 3x cubed in front. So this is already 3x, and you have x here. So what is the last term? It's basically will equals to x, correct? Because 3x times x only give you 3x cubed. Then for the last one is negative 8. So negative 1 times positive 2. And what do you need to times for you to get negative 8? It will be plus 4. Is that okay? So, but then you cannot try to guess like this. So you might need to write down to prove that how this is correct. So if x plus 4 is the factor for this polynomial, what will happen? So meaning that when you try to substitute your negative 4, you will actually get 0, correct? Let's try to write px here also. Okay, so let us try to substitute and check. Plus, negative 4, 18, negative 4, minus 8. Okay, so 3, you will need to times with negative 4 cubed, and then after that times with 3. Then you get negative 192. And then plus 17 times 16, so gives you 272, minus 372, then minus 8. Okay, so use your calculator to check. Negative 192 plus 272 minus 72 and minus 8. So and see whether you get 0. Yes, so it's 0. So we know that x plus 4 is the factor. Is that okay? So this is our try and error. So when we try to factorize it, then we need to rewrite the whole thing lah. Plus 17x squared plus 18x minus 8, it will be equals to 3x minus 1, x plus 2, and the last one is x plus 4. So you factorize completely. Alright, this is the first method. So second method, same thing, using long division. But of course, you already know that this one you can multiply is like what is given from the questions, right? So you wouldn't want to use this, and after that you need to factorize again. So it's basically you are using the whole thing, you divide, then you get your qx lah. So 3x cubed plus 17x squared plus 18x minus 8 when you divide by 3x squared plus 5x minus 2. Okay, so the same thing. How do you get 3x cubed from 3x squared? Then you need to times x. Okay, so 3x squared plus 15x squared minus 2x. And you're left with 2x squared minus minus become plus, okay, minus 8. Alright, so you check and see whether you can get it correct or not. So it's 2 here. Do I do something wrong? Times x, sorry, 5. Okay, so I should be able to get 12. Yeah, alright. So like when you do long division and you realize that this one, if you get a if you like just now I get a 2, right? So if I get a 2, then I realize that I cannot actually divide everything completely, then this is how you check that you do something wrong. Okay, so now it should be able to do it. Yeah, correct. So plus 4. Okay, so everything times 4, you get 12, then 20, and then negative 8. So everything becomes 0. Alright, so you know that your last factor should be x plus 4 lah. So but then make sure that when you try to write it in your last answer, it must be in the completely factorized form. So don't write this, okay? So make sure that you write the factorized one. And last one, x plus 4. Okay, alright, so that's for number 5. So let's move on for number 6. Alright, let's look at number 6. So the polynomial given is denoted by px. Is given that 2x minus 1 is a factor, and when it's divided by x minus 1, the remainder is negative 4. So you can definitely see that this question is a combination of both theorem, which the first information tells us about the factor theorem part, then the second part tells us about the remainder. Okay, but don't worry, it's basically they are talking about the same thing, because you know that the factor theorem actually comes from your remainder theorem, which the remainder is 0, so that's why it's the factor, right? So you just treat it like normal. How are you going to do that? So px will be equals to ax cubed plus x squared plus bx plus 6. Okay, so the same thing, if it's a factor, meaning that when you substitute, you should be able to get 0. So p1 over 2 gives you a remainder of 0. So the other one, when p1, it will gives you negative 4. Okay, so now the same thing, 2 equation, so simultaneous equation again. So substitution. So for this part is basically the thing that you should able to know how to continue already. So yeah, you can try to like do it yourself, then after that you compare your answer and so on. So equals to 6, 1 over 8, 1 over 4, 1 over 2. So let me try to multiply everything by 8. Okay, so you can just write down, like, depends on how you want to solve your equation lah, okay? So yeah, not necessary that you need to follow the step here. So this is the first one. So the second one, p substitute 1, you should able to get negative 4. So same thing, let's substitute 1 now. Okay, so a plus 7 plus b equals to negative 4. So meaning a will be equals to negative 4 and negative b minus 11. Okay, so this one is your second equation. So let us try to put them together. So a will be equals to negative 4b minus 50 equals to the other equation, negative b minus 11. So when I move it around, I get 3b. 3b, this one go there, then it gives me negative 39. So my b will be equals to 13. Wait, positive. Okay, so negative 13. Alright, so the same thing, let's go to the second part, the b, the a. So negative 13 minus 11. So 13 minus 11, which will gives me 2. Okay, so for this question, a equals to 2, b equals to negative 13. just like that. So what is important is actually like the first one. If you get the idea of how to put them inside your equation, then after that you solve it. That's like the normal arithmetic process for you. Okay, so you need to solve this cubic equation. So like quadratic equation, we are talking about degree 2. So this is basically a cubic equation. I know that you can do that with your calculator, but then yeah, we are going to solve it together here. Okay, so how are you going to do that? So for these questions, right, because you do not know any of the factor, so that's why your first thing is you must be able to find out what is your first factor first. So if you get the first one already, then you can use long division to continue if you don't want to do try and error. Or if you get the first one already, you can try to guess what is the other one might be. Then after that, you try to do comparison. Okay, so for these questions, x cubed plus 4x squared minus 19x plus 14 equals to 0. Okay, so for this question, right, you can definitely see that let's start with the logical thinking that we have just now, which what you can try to do is you can try to write down what is the possible factor first. Okay, so the same thing you can see in front here is like x cubed. So you know that it cannot be ax plus b, right? Because x cubed, so meaning that it should be like x plus what, or like x minus what. So after that, you can check your last number. So from the x cubed itself, you know that the possible number cannot be a fraction. So it will be like much more easier for you already. So for 14, what are the possible factors that when you multiply, then they can give you 14? So it can be positive negative 1, positive negative 2, positive negative 7, and positive negative 14. So since you do not have either any one of the factors, so what do you need to do? You need to check one by one. Okay, so substitute one by one and check whether the remainder is 0 or not, so that you know your first factor. Then after that, it will be much more easier. So let us start with the first one first. So maybe let's try to do it like in p negative 1. Okay, sorry, px. Okay, so this is my equation, so it's okay. Alright, px equals to x cubed plus 4x squared minus 19x plus 14. So I'll try with negative 1 first. Okay, so negative 1 cubed plus 4 negative 1 squared minus 19 negative 4 plus 14. So you can try to just check with your calculator, negative 4 plus 1 plus 19 plus 14. So you are getting 36. So 36 is definitely not equals to 0, so meaning it's a wrong one. So you will need to continue to check the other one. So how about P1? So 1 cubed plus 4, 1 squared minus 19, 1 plus 14. I think this is correct. So 1 plus 4, you get 5, 5 minus 19, 14, yeah, so you get 0. So you know that for the first one, x minus 1 is factor. Okay, so after you get 1 already, then what you can try to do? You definitely can do long division, right? So the first method that you can do is you do your long division. Okay, so if you are doing long division, then it will be x cubed plus 4x squared minus 19x plus 14. So you divide by x minus 1. Okay, so same thing, x squared. I'm going to do this like quickly because you should able to know how to continue. Minus, so 5x squared minus 19x, so plus 5x. 5x cubed minus 5x, so minus minus negative 14x plus 14, which means negative 1. So negative 14x plus 14, that gives me 0. Okay, sorry, 14. Alright, so you know that your when you try to factorize it, it should be equals to let me just copy it again. Plus 4x squared minus 19x plus 14 equals to 0, meaning it will be equals to x minus 1, x squared plus 5x minus 14 equals to 0. Okay, so you still need to expand it, like factorize it. So for this part, it should be 7 and 2. So x plus 7, x minus 2. So don't forget, this question not asking you to factorize, they ask you to solve. So meaning your x will be equals to 1, 2, and negative 7. Okay, alright, so this is how you can do it by the first method, which is by doing a long division. Okay, so the second one, what you can try to do is, yeah, so this will be your last answer. Second idea is you continue to do try and error, but with this first success, you can actually try to eliminate the possibility that it's wrong already. So how can I eliminate? You see, now I already tried the first two, right? Then after that, I left with 2, 7, and 14. So you can think of like what is the most possible answer it can be. Now you have x minus 1. So from the first failure here, you also know that x plus 1 is not the factor, correct? So from this question itself, you see, if I have x minus 1 already and x plus 1 is not, meaning that I can actually eliminate my 14. Right? So, okay, I mean, it's not eliminate. Of course, it can be x minus 1, then another x minus 1, then it can be 14 lah. But then the chances of it is maybe it will be like smaller. And I know that the other one, the positive one is not correct as well. So if I put like 1, then I need to divide it some other thing. Then 2 and 7 is the most possible, because 1 multiply 2 multiply 7, I get 14. So there is a chances that's like 1 multiply 1 and minus 14. But since positive 1 is wrong already, if this factor is not going to repeat, then 14 will not be correct. So that's why 2 and 7 is like most likely. So now, if you want to do try and error, then you can continue to do it. So meaning that, let's try with positive 2 maybe. Sorry, P2. Okay, will be equals to, then substitute again, 2 cubed plus 4, 2 minus 19, 2 plus 14. Okay, so this is like the calculation part. You wouldn't you actually do not need to write everything out, so just use your calculator to check everything lah. So 38 then plus 14, yeah, you are getting 0. So meaning you are getting the other one, x minus 2 is a factor also. Okay, then now you can try to write it out. So you already know that this 2 is the idea, so x minus 1 and x minus 2, and you left with the last one, correct? So you can try to guess negative 1 and negative 2, and now you need positive 14. So what is the last number that you will need to times? You are not going to pick negative 7, right? Because if positive, so if here is negative, you get positive, then if you times a negative again, then your 14 should be negative. But here is positive, so meaning that I would be guessing the last one should be x plus 7. So this is how I know that it's going to be 14. So now I'll need to check for negative 7 to confirm my guess. Okay, so negative 7 cubed plus 4, negative 7 square minus 19, negative 7 plus 14. Okay, so negative 7 cubed plus 4 times 49, and then minus 19 times 7 plus 14. Do I get anything wrong? Sorry. Negative 3, then plus 4 times 49 plus 19 times 7 and plus 14. Yeah, so I'm getting 0. So that's why I know that x plus 7 is the other factor. Okay, so you can write the exactly same thing now, that go back to exactly the same thing like this. But then you do not have this step anymore lah. It's okay, I try to write again. Okay, x cubed plus 4x squared minus 19x plus 14 equals to 0. So please make sure that you are not writing the px equals to, okay, because it must be in equation for you to solve it. So x plus 7, next one x plus minus 2, x minus 1, so equals to 0. So your x will be equals to negative 7, 1 and 2. So the same answer with what we have done previously. Okay, so that's the end for this first topic. So please try to finish up your exercise and so on. Alright, thank you.